How many people here have heartbeats? Nobody. Okay, so we're all dead. I'm going to be describing a little bit about metadata-driven testing. A lot of this is ways to avoid red flags, ways to avoid retyping things that you already knew. I was originally going to do a lot more on the adventure game, but most of the stuff just didn't look that exciting when I was done typing it, so I junked it. Everyone here play adventure? There we go. There is a version written entirely in Perl on GitHub that the Madison MadMongers have written. So this is some of the stuff I did to clean up the tests that we had for the adventure. Now, if you, Oh, yeah, sure. Is that better? Am I deafening everybody? So the basic thing with testing, there are different types of testing. Smoke testing, really, you're just asked, does it blow up? The CPAN reporter type testing. There's white box, black box testing, where you think you know what's inside or you think you don't know what's inside the object. Integration, regret, all of these different types of testing. You're doing a lot of different things with the test, but you're still trying to do the same basic operation. You're setting up a controlled environment. An unusual thing about the environment you're oftentimes setting up is you want to break things, which is not what you normally want to do to code. But you want to find ways that things fail. You want to find ways of screwing around with the code to see if it fails. You keep doing this over and over, either to improve your coverage, you want to make sure you've exercised all the code, you want to see what different ways things can handle failure in. So this is a look at ways of automating a lot of that process. Now, most of us started writing tests. You write a test, you make it work, you figure, oh good, it works, and now I want to test the next thing. So what do? You copy a test file and you edit it, and you keep doing this over and over. How many people here remember MJD's red flags? What's one of the first red flags? Cutting and pasting. Cutting and pasting is not lazy, because now what ends up happening to you is one day you realize there's a screw up in one of these tests, or you want to extend one of them, and now you have to go back and edit and cut and paste 45 files. So cutting and pasting is probably not the way you want to test. Another thing you get a lot of times, and you'll see this, you'll get this project that's been around for a while, and you've got a directory that's got 800 tests in it, and they're all in one directory. And if you want to run something, you want to see, you type prove, and you come back after dinner or something. It takes a 6-pack to finish testing it. You also get problems where the tests don't run in order, the tests don't do what you expect. The first piece of metadata you can use to control your testing is the file system. If you set the test space up correctly, you can do a lot better testing with a lot less work in a lot less time. So this is what the original version of the MadMongers tests look like. And you notice there are a lot of them, they're in one place. And you'll also notice they might not run in the order you expected them to. So the first piece of metadata I can give you, give consistent base names to your tests, so at least they run in the right order. Another thing is maybe you don't need to use all of the tests. You don't necessarily want to run them all every time. You probably got a subset that you do before check-in. You got more heavier duty things before you run for real. So what if we took the stuff you didn't run every time and pushed them into directories? You could say run the quick and dirty tests before a check-in, do something more for release. So now what I can do is make a couple of directories. So I've got a modules and the missions at the bottom, but I run the short ones up at the top. But now I don't even need all those long names anymore, and my title bar fits again. So a structure like this becomes a lot easier to manage. The metadata is things that are up in the top level of testing are lightweight. They do quick tests for whether you can use something. You do a prove -r to test all the things below it. Or you can take now a little bit more metadata. I can take things that are 0 star and make them really, really simple tests that I can run almost immediately. Take the ones, make them harder. Again, you can organize your tests so that they do what you need, they do them in the right order. Now, these things I haven't got out just with the file system. You name them consistently. There's another thing I can do. If you look at just about all of the tests that we have that examine particular files, they're called mission files, they all begin with pretty much the same two lines. I've got the package, adventure, and I've got the path to the actual config file. So what everyone did? They would copy the file, they would edit the path, they'd copy it, they'd edit it. But you notice something, it's going to be the same thing for all of these except for that one path. So let's make one slight change. Let's take all of the tests and base the name of the test on the file they're checking. At that point, all I have to do is symlink all of my config file names to one base test. It wakes up, it says, what's my name? It chops the T off the end of it and looks for a file that's that .yaml. Now I only have one file. I don't have to edit anything. I just symlink them all. Did that make sense to people? How many people have a heartbeat? Okay, oh hey, we're doing better. Somebody's alive at least. So now I can have a simple shell script that comes, it finds all of my YAML files, and one by one it just symlinks them into this directory full of tests. Done. If I add a new config file, bing. I run one shell script, I'm testing them all. The other nice thing about this, by the way, is then if I want to test one particular file, I can run one test and test one file. I can take a group of the names for the missions and have simple and complicated with the troll, without the troll, whatever I want, and I can use a glob to run a subset of tests. People for a long time, they said useOK was great, and then useOK got out of favor and says it's bad, it's evil. It's a really nice, quick, simple way to make sure you're not screwing yourself. It's not a complete test, but if you can't use the module, you're probably not going to do much else with it. Can we, grant me that much? So, another thing, how many people here write modules with packages? Use package names. How many people here have fat-fingered the name of a package? Yeah, okay. So one good check for that. If I use a module and then I check if the name that I think I installed can version, if I fat-finger the package name, there won't be a package with that name, and I can't version.
Well, you could also use package coding, that would make sure you had no typo. Put a double colon after propagation.
Yeah. Well, the check for version. The other thing is I then run version to make sure that it has a version. But you notice something here. I'm saying the word frobnicate over and over and over. If I wanted to test a whole bunch of modules, I'd have to copy this. So what's the first thing everyone would do if they saw this? You'd have a variable with the package name in it, right? And you know where this is going. If I can put this one name here, why can't I just take the base name and stick it into the variable? Strip off the number, split a path apart on non-words, and I can actually symlink one test to test all my modules. So if I want to test Acme eyedrops, I just do a symlink for this generic test to the Acme eyedrops.t. Again, I can use the file system as metadata. Better than that, I can do something like this. There'll be a quiz at the end of this, free beer for anyone that remembers the entire script, but I can find all of my .pms and symlink all of them in one pass to a single generic test. Run the shell script, type proof. I've just validated that every one of my modules at least compiles, which is nice because then I can do something with a find. I can do approve 01.t, test them all in one pass. I can test them in parallel if I want to. I can do approve and get tag. One really nice thing with this is, if anyone here ever had a file that broke your nightly build? Yeah. Well, with this, at least if everyone who checks in does approve, and I tag it, I can grab on a daily basis all the most recent tags in Git and merge those. I don't have to care if everyone's committing only working code to the branch. I'm going to grab the last stuff that passed the initial tests. Everyone here ever you fat-fingered a JSON file, that's easy to do, or missed a tag in XML? You can do the same thing. You can waste all night trying to figure out why your code doesn't work and realize, oh yeah, it was a config file. Everyone here use config any? Ever seen that? Anyone? Okay, well, it'll read just about any type of configuration file and dump it into a Perl struct. It uses the content and the extension. You can have XMLs, you can have anything. But that means you've got a whole bunch of configuration files in your directory. You can pass all of them through config any and ask at least if they're well formed. So again, I can, same thing that I did with the PMs, I can do with YAMLs. I can symlink them to a single test, run a shell script once, and I can check all my config files. So this will sit there, it'll find all of the tests in my tbin directory, and it will very quickly make links to test everything that I've got, config files, Perl modules, whatever else I want. So now I can reuse everything in multiple directories. I can use the same idea across projects. So instead of having to, every time I start a new project, I don't have to sit there and copy 800 tests. I take a couple of generic tests, I put them in the T directory, and run a shell script. Done. I can test all the different projects I want. Has anyone here ever run a test on the wrong database? Yeah, you run the test and suddenly the accounting department wants to string you up. So one way to solve that is you can take configuration modules or configuration files, put them in T/etc. At that point, there's a module I wrote called find bin libs that will find things looking up the file path. It'll use libraries starting from where you are and walk up. Okay, don't use it. But at that point, I can use a config file, and if there's a config in tlib, I'll prefer that one. If I use a lookup like this, I can find all the things that are etc from my point up the file system and find the first one that exists. Things that are running as tests will prefer t/etc. Things that are running normally will prefer something further up the file system. At that point, if I have a configuration file in my T directory, or I use a configuration module, I can just not configure it to know about production. Makes it a lot harder for people to blow their kneecaps off. Another thing that's kind of fun about Perl is that, unlike most languages, you can dispatch something. Everyone's seen this call. You have a method name, you put it in. But you realize you can have a method name, and you can dispatch something by storing the name of a method in a scalar and dispatching that. You can even use a code ref. I can dispatch an object anywhere that I want to. At that point, in Perl 6, it looks a little different because you can dispatch to a bare code ref, or if you have a name, you have to put it in quotes. But you can still do the same basic thing. At that point, if I have a list of methods, just a list of method names, I can call one particular object with a whole bunch of method names and pass it some arguments. If there are different ways of opening the file, read, write, or whatever, I can pass a whole bunch of things into it. So I can have metadata that's stored outside my program that gives me the list of methods. Another module I wrote, Object Exercise, came out of a project where I was writing the metadata manager for a database. And I had to create one element in the database for a data set, and then create queries against it, and then run the queries. And each one of these depended on previous ones, but the entire test was the same object points to a method with a bunch of arguments, and then check what I got back and compare it to a value, and then display a message. So I wrote a module that does that. It takes a data structure and it iterates calling your object with a method and some arguments, compares it to a return, and then displays a message. Well, at that point, because the method is stored as text, I don't need code for it. I can have something where I store a flat list and just create the object and dispatch it. Actually, I dispatch it into a thing called $exercise that the module exports. And by dispatching into a code ref, I don't collide with any method names that are in the existing module. But, what's wrong?
Yay.
Yeah, well, yeah, I said well, you can test this unless you have a variable named $exercise, and you can even change that. But at that point, instead of hardwiring those tests, I can have a subroutine called generate plan that can read a piece of YAML. It can query a database to find all the tables in the database. If you've got something in your code that tries to check whether it can query a table, I can actually have something that goes out to a database, looks up in the data dictionary, show me all the tables that have a particular column in them. Select column from table name. I can manufacture the SQL on the fly. So I can have a test, I can store an external YAML file, and now I can have one generic test. You know where this is going. Symlink to the name of a YAML file that finds its base name, reads the test configuration in, and runs all my tests. Now, if I want people to be testing stuff, they don't have to be hacking code. They don't even have to know how Perl works. Depending on how you write the flat file, they don't even have to know how YAML works. You could do it with an ini file, you could do it with XML, you could do it with CSVs for all I care. You can put this data anywhere you want it and be able to run anything you want to with Perl. So one of the other things you have, and this is, how many people here have read the Perl testing notebook? That blue thing with the fake coffee stains on it? Do yourselves a favor. Just find, it's out of print. There are copies for like $1.50 on Amazon and eBay. Grab one. I mean, I could live without the fake coffee stains, but the book shows some really excellent ways to test things. One of the things that it shows is how to hack Perl core. So people here are used to local, right? I don't have to explain that. So local, usually you think of it with something like $/ for print and new lines, or taking standard out and dumping it into a file. But I can use local to hack the Perl core. And I'm not going to go into all the niceties of how to go about it, but let's just say I want to check a bunch of methods in my code for whether or not they can handle a failed open on a file. All right, that's something we all want to do. And everyone's tried different ways. You know, you create a temporary directory in temp based on your process ID, and then try and open a file whose name you don't think you know, and then the test runs twice, and you forgot to unlink the file, and now you're not really testing it anymore because you're testing artifacts of a leftover test. Well, don't hack the file system, hack Perl. I can write a test that will guarantee that I fail anytime I try and open, because I've localized it. I'm not going to break all of Perl while I'm running. I'm just going to break it in the context of making this one method call. If I do this, if I run this sub, I can dispatch my object into it and say, hey, I know now that it correctly handles failed opens. More important, though, and I did this because we had one project that sometimes we couldn't tell why it was going to fail. And it turned out that depending on what path you took through, there was an order of execution issue. One guy in one place had wrapped the failure to open one of the config files in one too many evals, and he wasn't passing the error up the stack. So we couldn't tell that we had failed to open that one config file, but only if we went through the code in a certain order. So one of the things you might want to say is, I want to run this, but I want to fail on each individual config file separately and convince myself that I can successfully detect failing on that one config file. This will do exactly that. So now I can create a test that if you give me a list of configuration files, I will generate a closure for each one of them that fails on exactly that one file, and then follows the file system for the rest of it. I can then iterate all those with object exercise or a for loop if you want to. And I can say, okay, run a method that does my baseline configuration, failing on that one file, or failing on one module, or failing on one whatever. I can make anything I want to fail one time this way. So at that point, I can have a map. I just generate one of these fail on configs, create a plan that says, okay, the thing I'm dispatching with, instead of using a method name, I'm going to use a closure that knows how to fry one file. Or knows how to, again, if you're connecting to the database and you connect to 4 databases, you can make something that will always fail to connect to one of the databases, or always fail to connect to one of the services, DNS versus HTTP. Can I correctly handle the fact that I know that I didn't connect to something? But I'm not cutting and pasting anything here. All I'm doing is feeding data into something that generates failures for that one case. Again, I can use base names or a flat file to configure what I'm going to fail on. Another classic problem, not all files have got bookends at both ends of them, ini and YAML. If you get a runt read off the file system, you may not be able to tell that you got to the end, didn't get to the end of it. Does that make sense? Hello? Yes. Okay. So at that point, one of the things I want to check, can I correctly handle the fact that I didn't read all the file? Do I just get an error message? Well, this is something that I can, again, configure externally. I'm going to wrap a method that does whatever my open is, and for a particular path, for just one of the paths, I'm going to say, fine, read it off the disk drive, and then return a substr of it, a random substring. Well, I can run this 100 times and ask, gee, do I successfully detect the fact that only half of my configuration file got read? Do I validate my configuration properly? Again, a lot of places I've seen, fine, we put this thing in memory. We know it's right because we read it from the disk drive. And at 3 in the morning, something fails every Thursday because there's a job that cleans up the disk drive, and it literally, this one thing went through, and it shortened all the files to 4K because it thought they were logs. And once a week, all of our configuration files got chopped in half.
Do you have an HDMI to mini DisplayPort adapter on that method? We need it in another room, like the small white cables. Yeah. Sorry.
Why the hell? I got one in my book bag if you need it. Thank you. But then I can return random. If you have constants that you're supposed to be able to detect something larger, this thing could hack the configuration. It could read the config file and store -1 for the upper limit of something. You can break things however you like using this basic technique. So I can have a general thing that looks for a glob. It looks for all of my configuration files. It'll take each one, generate a runt read for it, generate something that takes whatever package I'm in and does the read config, and generates a closure that will fail for that one file. Well, notice I don't have to cut and paste anything in order to fail on these config files. All I have to pass it is a glob somewhere. Now, other things you can do with this, if you think about it, people here use the stat function call, check for read, write, size, whatever. I can override stat. I can force one particular file to be unreadable. I can force every file that I've got on the system to be owned by super user or a non-existent user. I can take everything everywhere and say that it was updated 2 years ago. Anything that you're supposed to validate, you can break without having to futz around on the file system and generate fake files with bad timestamps on them. So the point here is, to configure this stuff, you can push all of the data about what you're testing outside and then hack the environment to match it while you're running. Now, one problem with these tests, if I do a map like this, I mean, I have to run all of my tests every time because I'm iterating all of them. Another way to do the same basic thing is to have a shell script generate one test for each config file, and then do a read on that config file. The disadvantage of that is you can end up with a test directory with 1,000 tests in it. The advantage is you can run a subset. Another way to do it is take the glob and run the A configs and the B configs and C configs, take different types of things, chunk it into smaller groups of tests, but it's not that hard to do. And again, it's all data-driven after that point. You run a script or you update one config file, and all of your tests are driven by that. And one thing, there was a talk, I think, before on writing testable code. The first thing you notice about this, if you've got the one subroutine from hell that does all of the read and import and evaluate and configure and install and validate in one place, it becomes hard to test it progressively this way because you're going to have to fake out different pieces of it. So again, one thing that if you're going to use this kind of data-driven, metadata-driven testing, it's a good idea to write things in smaller chunks so that you can break them in smaller chunks. And it's easier to configure the tests to test small pieces. So as a simple thing, for the adventure game, those mission files look kind of like this. This is the simplest mission file. This is the black hole. So if you look here, the locations in the map are the black hole. You start out in it, and there's one exit back into the black hole. Not much fun to play the game. But this is neat if what I want to do is check, does the game transition from one place to the next correctly? I can ask if I can exit the black hole. It's pretty easy to figure out where I'm going to be. I've got a very predictable result. Another thing I can do with it, aside from just using the exit and asking, am I in the same place, I can ask, well, wait a minute, is there a memory leak in moving between places? Am I pushing stuff onto a stack that I'm not doing very well? I can very quickly move out of the black hole 1,000,000 times and ask, gee, did I successfully make the move? Is the memory changing? Now, the downside of doing it this exact way is I'm going to have 1,000,000 OKs streaming by on the screen, which one other trick you have if you're doing a lot of this metadata-driven testing, it's very easy to do large ranges, but you might not want to print an OK for every one of them. So what I can do instead is have a limit. I can iterate running through this thing, and I can check, does it blow up and do a fail? So if I go the whole 1,000,000 times, I'll get to an OK, but you can stop the thing where you know that the check failed. Another thing is I can do, if I have the sum size, if people saw a talk I did once before on memory manglement in Perl, the basic conclusion of was size does matter. You can take the size of a structure. If I look at the size of my map, if I look at the size of a bunch of items, I can create a generic test that asks, for a given list of objects, is their size changing? Does it grow by more than 10%, let's say? So I can sum the sizes before and after, and if my prior limit, 10% more than the sum of the sizes, is still greater than what I've got at the end, I know I'm probably not dealing with any severe memory leaks. Does this make sense to people? Anyone here ever run into a memory leak? Yeah, okay. This is a generic test for it. So I can init the game with a file. I can make a daisy chain map. You remember what that thing looked like with the ins and outs. Generating a new map for that is not complicated if every room has got exactly one exit, and it's room X+1. So I can now, again, without having to cut and paste anything, I can generate a generic map this way. I can now test it for 1,000,000 little tiny rooms. I can ask, can I get to the next room 1,000,000 times? I can ask, do I have a memory leak where I'm storing too much data and I'm going to blow up? I can have a room on the left and the right. I can go left and right and keep going back. By generating the maps instead of storing them, I don't have to edit these maps every time I want a new test. Playing with the web. Anyone here do work on web apps? Anyone ever told, hey, we can't test that, the back end isn't running yet? Well, plaque and selenium together make what I call a selenium sandwich. Tasty, nutritious, and saves you a lot of trouble. The trick is, if I start up plaque with selenium, I can wake up a browser that's pointed back to my server. Did that make sense? I'm getting a few nods at least. At that point, I can have a structure that says fill this into the DOM, poke submit. But I know that the browser is talking to me. I know what it should hand me back. So I can have an array ref with what I need to test out of the request. I can then return something, and I can check the DOM on the other end and make sure that it displayed it properly. Anyone here ever had problems where you were supposed to test 404, 403, a 500, make sure that the browser handles a 500 correctly? You want to handle errors. You want to make sure that the stuff on the front end, if the back end crashes, has an appropriate message, right? So now the problem usually is, oh, how am I going to make the back end crash and send a 500 message? How am I going to get it to send a 404 or 403 error or a redirect or something? Well, it's pretty easy here because in my return structure, if the first element is 403, that's what they're getting back. I can now test all the data. I can generate this data. I can put it out. I can have people tell me, what are we filling in? What's it supposed to look like? What am I supposed to see when we click submit? This is all spec. It's not code. I don't have to write code in order to test the front end of my browser. Another neat thing is if I save the expected values that come back from the browser after I've validated them, I now have all the tests from my back end because I know what I'm supposed to be sending it. So I can generate for Exploder, for Firefox, for Opera, for every browser that I can talk to with Selenium, I can generate test data sets for the back end that really do look like what that, they're no mock objects. There's actual data. So again, if I want to return an HTTP failure code, fine. You filled out everything right, I just handed you a 404. If you want to test a range of these things, it's all data. You're not having to write off-ball code that knows how to return the stuff. You're just reading something up and spitting it back out. So the real summary is a lot of testing that I've seen has a lot. The red flags are that people are editing and changing and editing and copying and changing. Don't. Write code that's driven by the data and then use the tests. The tests become the data. The metadata might be the file system, it might be flat files, it might be a combination of both, but you can use the data that you know about the product, whatever you're working on, in order to drive all the tests without having to do all the cutting and pasting. If you look me up, there's Object Exercise, the Selenium Sandwich has got some talks. There's one I did a few years ago on getting testy with Perl that shows how to run a lot of these tests and how to do some more of it if you want more detail on that thing. Bedside toilet, whatever you need it for. And that's it. Was that useful? How many people are awake? Okay, at least I kept people awake. Are there any questions? I mean, has anyone ever tried doing this kind of stuff in testing? Any experiences people have with, I'm getting some nods, what kind of stuff do you test with it?
I've basically mocked a lot of Perl core in order to make sure that I can raise the correct kind of values that I want.
Okay, so have you done anything, well, so the thing he was pointing out is, yeah, one of the things he's done in testing is hack Perl core so that you can generate the kind of errors that you want to see. Have you tried anything like this with dispatching through a closure that localizes the change, or do you just hack it in the test?
No, it's a standalone test.
Each one of them. Would that seem like it's useful to you to be able to generate these failures, or?
The thing is that I don't know how far frequently you need to stretch. Because like if you start templating it out really heavily, it's kind of curious to me whether or not the incorporated pattern doesn't extend.
Okay. Well, because the one thing you could do, I didn't show it here, if you know that you got to break different collections of pieces in core, there's nothing to keep you from having a library in the T directory that has broken open, broken stat, broken this, broken, and it breaks it in all specific ways. And you write all your tests to say, call this one function, passing in an object and a method, or passing it a closure to run. And you can say, fine, this is now broken, run it, come back. So that's another way, again, you can help configure this without doing copies. Put all the breakage into one module, use it in your test, and then you can call something that knows it has a broken stat or a broken open. Does anyone else here use data for your testing? What do you do with it?
For example, I have a subset interaction with our Go system that does Git-related calls. And so I model a lot of those calls to see if our parsing works properly without having to, basically I have a huge set of tables and things like that. It's kind of the same thing to do the work without actually calling Git.
So your interactions with Git, you've table-driven the tests for whether you can do the Git operations. Anyone else? So this might be helpful for a lot. What do you do with the?
Well, I'm going to, you being humble over here, so I'm going to talk more. There was a talk yesterday about test.ml and using this sort of at a really, really grand scale. He even showed putting the picture data in.
Oh, yeah, so yeah, you can have a meta language for all the testing. But that's the point is if laziness isn't hacking test files 500 times. It's coming up with one test that's flexible. And the meta language is one way to do that. Even this, which is straight Perl, if you've got a bunch of functions that say like they'll break open for one specific file, it's easy to write. And then depending on how you like to do that, you can mangle your config file reading, you can mangle network interactions, you can misdirect DNS, you can open dev null as your input file, you can do all those sorts of things. And a lot of it, you get into things. I worked for a hedge fund once, and there were problems like during the financial meltdown, people were buying U.S. Treasury bonds at higher than face value, just because they weren't going down as fast as stocks were. Well, that meant that the rate of return got negative. So there was all kinds of setups around where people were validating the input data that were rejecting legitimate data because they never figured that T-bills would be negative. So a lot of times you can, if you're doing this data-driven testing, you can get better coverage, you can validate things pretty easily because you can say, okay, let's put some insane values in it and make sure they work. And it's a lot easier, again, to put those into a flat file, let the flat file drive your testing, and not have to worry about hacking all the tests for all the configurations. You can have something generate all the flat files with ranges of data. But yeah, the test.ml, that's a good way to do it too. Write yourself a small language for running the tests, and just use that to describe your tests. But don't cut and paste. Anyway, that's it, I guess. I'm just about on time.
You've got 12 minutes.
Oh, dear.
You don't have to fill it. It's okay.
Yeah, if anyone wants to eat, if anyone wants to pick my brain, I'm here. And it worked. A shell scripted function, what do you know?